Hello everyone, welcome to another episode of Data in Charge LinkedIn Live Sessions powered by Volt Active Data. Today's topic is one that almost every modern trading platform wrestles with: building a real-time order management system for crypto that is fast, transactional, correct, and simple enough to actually operate in production. So if you see, we say we need to look beyond cash plus RDBMS patterns, because combo is where most team starts, and it also where most team hits a wall. Today we will see why and how a unified approach with Volt Active Data can solve this. My name is Biplab Banerjee and I work here as a director of Presales. Today we'll look at the challenge, how challenging it is to operate an order management system under heavy concurrent load, what Volt Active Data platform is. We'll look at a transactionally consistent architecture with Volt Active Data, followed by a live demonstration. And we'll reconvene with some quick summary at the end of this session. Let's look at the challenges. Crypto market never sleeps. Orders, trades, wallets, continuously running 24/7 and increasingly bot-driven. The business expects three things at the same time: instant acknowledgement of every order, a live accurate view of exposures and order status, and risk decisions taken before exposure is created, not after every end of day reconciliation. When you can't do this, the impact is real. Missed trading opportunities, wrong exposures shown to customers, regulator questions, and reconciliation work that piles up every single day. And remember, volatility plus algo trading creates hotspots. Traditional architecture adoption brings in technical challenges. Every incoming order needs an immediate decision based on wallet balance, locked funds, current position, and the user's open orders, all of which are changing concurrently. A typical architectural pattern is usage of a cache plus a relational database. Redis or of similar sort, an in-memory cache, plus a relational database, maybe a Postgres or a MySQL. This looks fine in whiteboard. In production, it gives you lots of problems. The first is stale reads from the cache. The second is cache invalidation logic that grows forever. The third is dual write consistency risks. The cache says one thing, the database says another, and your customer sees the wrong balance. This is exactly where Volt Active Data comes in. Volt is a unified real-time data platform, and it provides high throughput ingestion of orders and trades, gives you the full asset transaction processing guarantees with real-time SQL analytics on the very same operational state. No cache layer, no separate analytics store for live queries, no glue code, one system, single source of truth, microsecond decisions. Now let's look at the architecture with Volt. Orders and trade requests comes in from APIs, market feeds, and bots. They hit an application service which calls Volt transactions. Those transactions executed in an atomic, full ACID guaranteed way, completing the validate, decide, update cycle in a single shot. Volt provides serializable isolation per partition. So you can partition your tables where your data will be co-located across different tables, which makes it easier to read as well as write from single partition and avoid cross-partition coordinations. Volt provides in-memory transaction processing with full durability and HA. It also provides linear horizontal scalability so that you can scale as and when your workload grows. Most of the time you need the data on downstream analytical systems. Volt provides CDC features and exports so that you can push your decisions or process data out to downstream systems. Now let's look at a real implementation with Volt. Here on the screen, you see the Volt Management Center, the UI for Volt platform. Let's look at the schemas. So we have four major tables here: the order request table to capture the orders, a position table to maintain the position of the users, a trades table, and a wallet table per user. All of these tables are partitioned on the user ID. Now we have some transactions that would be invoked while we place the orders. So we have a place order transaction. When a user places an order, this request is invoked and the order state is captured. Simultaneously, the requests are also submitted to the exchange. When exchange is able to fulfill the orders, the state is being continuously captured in Volt. An order request need not be fulfilled immediately, so it could be fulfilled or partially fulfilled. Now let me just start the workload and let's see what happens. We have built a VoltDB client. Now in the screen, you could see a command that will be invoked, which will simulate some order requests and trade completion for those requests, the state of which will be maintained in Volt. We are simulating about 1 million users and all of their wallets are pre-filled with some positions already holding for different symbols. So we would be running somewhere around 50K order transactions per second, and we'll try to fulfill trades at the rate of 50K transactions per second. So in total, it should be around 100K transactions per second on VoltDB. So let's start the workload. So if you see, the workload has started. The client application has connected to all the 3 nodes of the Volt cluster. Now here we see the actual transactions coming up. So you could see we are almost achieving our targets of about 100K transactions per second with average latencies of about 2 milliseconds and P95 latencies about 3 milliseconds. If we go back to our UI, here in our UI, we could see our CPUs at about 40% consumption. We are almost achieving 100K transactions per second, and our P99 latencies of the cluster are well below 10 milliseconds. Now, while these workloads are running, let's run some real-time queries. Now, these queries will help us understand how Volt could help you do real-time analytics. So let's say we have this query to understand what is the global order count at this moment. So what I have done is I have created some materialized views on top of the base tables. Volt supports materialized views. These are continuous counters, and the results of these counters are cached. You could directly query them. So in my case, I've created a materialized view on the order table, similarly on trades table, and some other tables as well. Now let's query them. So I just want to understand what's the global order count right at this moment. I'll just run this query on the materialized view, and I'm getting the counts that's constantly changing. Right? Similarly, if I want to understand what's the state of my global trade count, I could query the materialized view that I created on top of the trades table. And we have a continuous counter of the global trade count constantly updated. If I want to look at the order count by status, we can run this query on the materialized view and we'll see results of the counts per status. So you could see we have different status like filled, partially filled, and order placed, and these are their respective counts, and these counts are constantly changing as and when we fire them. So this is how you can do real-time analytics as well on Volt active data. Now that our workload has ended, let's just have a look on what are the results. So we could see here that we have a huge amount of orders placed, none of them were rejected, and a huge amount of trades that were executed, and we were able to achieve all of this at a throughput of about 100K transactions per second with average latencies of about 2 milliseconds, P99 being single digit 5 milliseconds. Now that's the kind of performance Volt provides to you, along with all the facilities of real-time analytics that you could query on Volt. Summing up, so what we understood is Volt is a platform that could help you unify transaction processing with full asset guarantees and real-time analytics in a single platform without any kind of glue codes. It helps you take millisecond decisions. Business logic co-located near to the data is applied on every event as it arrives, enabling instant operational responses. It provides simplicity with production-grade reliability, all using simple SQL logic, provides you the horizontal scalability, HA, and georesiliency. If you are interested in trying out this demo, please do visit www.voltactivedata.com/buildwithvolt. You can find this demo as well as many more such demos. Go and try out. Do not forget to like, share, comment, and follow our page. I am reachable on LinkedIn. Feel free to connect with me. Thank you.